In this video, we'll convert numbers smaller than 1 but bigger than 0 to scientific notation. So smaller than 1 means 0 point something because it's more than 0, so it has to be 0 point, but less than 1. So maybe 0.1 or 0.01 and 0.001, which means 1/10, 1/100th, 1/1000th. I'm picking these numbers just because I want to remind you that 1/10 means 1 over 10, which is 10 to the negative first, because when we have a negative exponent, that means division. 1/100th means 1 over 100, which is 1 over 10 to the second power, which is 10 to the negative second. So if I divide 1 by 10 and by 10 again, which means 1 over 100, that is 1/100th. Or 1/1000th is 1 divided by 1,000, which is 1 over 10 to the third power, which is 10 to the negative 3. So if I go backwards, 10 to the negative 3 means dividing 1 by 10 3 times, which is 1 over 1,000, which becomes thousandths place. That is really important for converting numbers to scientific notation and have a decimal involved. In scientific notation, we must have a number that is between 1 and 9, so a quick reminder, times the power of 10, that could be positive or negative. And today, since we're talking about digits that are less than 1 but bigger than 0, our exponents will be negative. So the number for the scientific notation has to have, again, a number between 1 and 9, so it can be 1 point something, 2 point something, 3 point something, 4 point something, and times a base of 10 to a certain exponent. So we can't have in scientific notation 0 point something. We have to have 1, 2, 3, 4, and a decimal behind. So 5, 6, 7, 8, and 9. Those are the allowed numbers for the scientific notation. So it has to be one digit. How many digits are behind decimal? It doesn't matter. You have to have a power of 10. The power of 10 can be positive or negative. So in scientific notation, it's important to have just one digit that is not a 0. 0 is not allowed, or two-digit numbers are not allowed. So you can't use a 10. So right here is the important part to remember. The power of 10 can be positive, negative, 0, so it depends. Let's say -4, -3, -2, -1, 0, 1, 2, 3, 4. Any number that has a negative exponent will be representing division, so they will become small numbers. 10 to the 0 power is multiplied by 1, so the number remains the same, and then positive exponents enlarge the numbers. So let's look at the examples that we have for today. Today, we want to convert numbers smaller than 1 and bigger than 0. In scientific notation, we're going to place the decimal after the first significant digit, 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we will multiply by the power of 10 that represents the place value of the first non-digit number. It means non-zero number. It's going to be after the first number that it's not a 0, non-zero number. The power of 10 this time is going to be negative because we're looking at small numbers, smaller than 1, and they are representing negative exponents. So 0.5, it's 5/10. So that means 5 divided by 10. Now this number in scientific notation is going to be 5 multiplied by 10 to the negative 1. 5 is in tens place. Tens place means divide by 10. So if I have one digit behind the decimal, I'm multiplying by 10 to the negative 1. 0.03 and 2. So the first non-zero digit, non-zero means not a zero from left to right. 3 is in the hundreds place. That means I have to have 3.2, so the decimal goes after the first non-zero digit, 3, then I put the 0.2 and multiply by the power of 10, representing hundreds place. That means negative 2. Hundreds is division by 100. Division by 100 from our review is 1 divided by 10 to the second power, which is 10 to the negative 2. So 3 being in the hundreds place, it is the second digit behind the decimal times 10 to the negative 2. So 2 digits behind the decimal, negative 2. Let's observe the pattern a little further. So I have 0.004. 4 is the third digit behind the decimal, so it is in the thousands place. So the number of digits behind the decimal is really important because it's the place value. That's when we put the decimal after the 4. So we place the decimal after the first significant digit that it's not a 0. So we have 0, 0, 0, and 4 is the first one that it's not a 0. So we put the decimal behind, bring the 8 and the 3, and then multiply by the power of 10 representing thousands place. That is 10 to the negative 3. Since it's a small number, it is division involved. So let's see here. 4.83 times 10 to the negative 3 means 4.83, and then divide by 10, divide by 10 again, and then divide by 10 one more time. And that is my original number right here. 0.004 is in my hundreds place and 83. So we can check my answer by using that division again. Let's see the next example. 0.000, and then 1 is in the fourth place behind the decimal. So that means we place the decimal after the first significant digit, that it's not a 0, so the decimal goes after 1. Then we think, okay, that is after the decimal involving 1, 2, 3, 4 digits. So after I place the decimal behind 1, I put 0.29, and then the power of 10 will be negative 4. Because 1 is in the fourth place behind the decimal. Okay, let's check that. So 1.029, and I have to divide by 10 4 times. So here I go, divide by 10. See how the decimal is moving. Divide by 10. 1.029, divide by 10. Divide by 10, divide by 10, that was third time, and then divide by 10 fourth time. And we have our original number, 0 with the decimal, then we have 3 zeros, and then we have the 1, the 0, the 2, and the 9. So 1.029 multiplied by 10 to the negative 4th means divide by 10 4 times, and our decimal point is moving to the left till original number. Let's see the pattern here. 0.1234 digits. 9 is in the fifth place behind the decimal. So this number of digits is going to be the power of 10 negative. So we place the decimal after 9 because the decimal goes after the first significant digit, all the zeros, and 9 is the first non-zero. So the decimal goes behind 9. You can say 9 or 9.0 or just 9. And then times the power of 10 will be negative 5. That means if I divide 9 by 10 5 times, I'm going to get that number. So let's see here, 9 divide by 10, divide by 10, divide by 10, or I can divide by 1, 2, 3, 4, 5 zeros. That's 100,000 equals, and here's my original number, 1, 2, 3, 4, 5 digits behind the decimal, with 9 being the last. Seven is the first non-zero number. To get to 7, we have behind the decimal 1, 2, 3, 4, 5 zeros, and then the 7 is in the 6th place. So that means I put the decimal after 7, which I need to bring now the 2, the 3, the 6, and the 7 next to it, but the decimal goes after the first significant digit, multiply by 10, raised to the power of how many digits you have behind the decimal, including the 7. So 1, 2, 3, 4, 5, 6. Negative 6. So that means if I divide 7 by 10 6 times, with every division the number becomes smaller and smaller and smaller and smaller, and that will come back to the original number here. And the last one, 6 is my first significant digit that is not a 0, going left to right. So I put the decimal behind 6, 6.8. The power of 10 is showing a very, very small number. It means that I have to divide the 6 many, many, many times. So 6 has to be divided. In other words, multiplied by a negative power. How many times do I need to divide? 1, 2, 3, 4, 5, 6, 7. That will be negative 7. So 6.8, if I divide 6 by 10, 7 times, 6.8 divided by 1 with 1, 2, 3, 4, 5, 6, 7 zeros. That is my original number. 1, 2, 3, 4, 5, 6, 7 is the number of digits, including 6, and then the 0.8. To practice, I have a mixture of a few different examples. Let's see here. I need to convert each number to scientific notation. So first of all, those are large numbers. I have large numbers. They will represent positive exponents. These ones are small numbers. They're bigger than 0 but smaller than 1. They're all 0 point something. So they will be negative exponents. So on this side I have positive exponents involved for the power of 10. On this side I have negative exponents involved for the power of 10. We're going to go over the answers a little bit later. I need you to follow our notes and examples to see if you can figure out what goes in this column with scientific notation using powers of 10 that are positive, and on this column power of 10 that is negative. Here we have to circle all the numbers that are in scientific notation. They all appear to be in scientific notation because they have power of 10. However, a quick reminder about how the numbers should look in scientific notation. We must have only one significant digit, then the decimal, then a power of 10. So we can't have a 0 and we can't have any 2-digit numbers. Would you give this a try, please?